Okay.
Hi, good afternoon.
Hey, good afternoon, man.
Hi.
Hi, everybody. What's showing the practical to someone today? Yeah, let me see what we have done. Okay, that's fine. And how is this going on? Perfect, right? So all we have the configuration, right? So what we have done, guys, if you remember that we have covered the almost every topic of the EIGRP. The one part we have last, right? We have covered the, if you guys remember that we have covered the EIGRP name mode as stop and the route filtering concept. We have seen the last classes, the ACL concept, like ACL, we have a two types of ACL, standard ACL and extended ACL. These are called as a numbered ACL, right? At the same time, we have a named ACL as well. So you, instead of the number, you can define the name for that one. So in the only the difference is that in the numbered ACL, what happened, you cannot change the you cannot modify the sequence number. In the named, you can modify the sequence number over there, right? So in a route filtering, if you remember that, we have covered this part. If you see that, access list deny permit one this 2.0, 3.0, and you can distribute this apply in the inbound direction on the router number one, and it's gonna deny the certain route, right? One, it's gonna deny the 4, 5, 6, 7. It's only gonna allow the 1, 2, 3, right? Okay, let me mute everyone. So I'm not denying it. The ACL is a bad thing, right? In a production, you are seeing the ACL as well. But the problem is that of the ACL, you know what? The problem with the ACL, right? Access control list, right? See, if you have a one entry, two entry, or 10 entries, even if the 10 entries you have, that's fine. Not a big deal. 20 entries, fine. 20 entries means what? I'm seeing the permit 1.0, permit 2.0, deny 3.0, permit 4.0, permit 5.0, permit 6. These are called as entries, right? If you have a 10, 20s, that's fine. But if you have a bulky entry, like a 100 plus entries, if you have 200 plus entries, in that case, what happened? ACL will put the lots of load on the router side. So if I talk about the, load perspective, so ACL put the lots of load on the router side. So it's take a lots of CPU and lots of memory as well. That's a one of the major issue with the ACL. Second ACL issue is what? The, if I'm gonna put the prefix like that way, take example, I have over there. Yeah, it's there. So take example, if you have a prefix like this way, not now, like this way, now you have prefix like this way. So take example, we have a, when I was here, 2.0 as a /26, I can call it. Then we have a, when I was here 1.0/24, I can call it. And then we have a, this guy should be go with the 25, and this guy go with the 26. So take example, if you have all the classless route, you can see that right now, 1, 2, 3, 4, 5, 6, 7, right? And all they have a 24, 25, 26, 27. If you're gonna filter these kind of cloud with the help of ACL, right? So you need to put the extra statement. Extra statement, so you need to put the extra entries. Or see, I'm not saying it's not possible to filter this route with the help of ACL. It's possible, but the thing is that the ACL is not so much scalable, right? Because in an ACL, normally what happened, if you remember that, in an ACL, normally we are matching the bits based on the wildcard mask. We are matching the bits based on the wildcard mask, and then we are doing the filtering. So to avoid this kind of issues, right, we came with the concept is known as a prefix list. So as the name suggests that, right, it's a prefix, right? So prefix means what? A route. A route list means what? Entries we have, right? So it's a route entries, right? Based on the prefix list, now we can allow and deny the route. Now, if I'm compared with the ACL, the prefix list, right? Prefix list is a very light in weight. Lightweight means what? It take a very low processing power of the router, very low memory and very low CPU if you compare with the ACL. So take example, if I'm going to say that the one ACL is going to consume almost 40 bytes of memory, Whereas the prefix list, one prefix list is going to consume the near around 30 to 25 bytes of memory. So that's a benefit you have. Another thing is that prefix list is more scalable than the ACL. So in a production network, you will see the combination of both the things. You will see the ACL and you will see the prefix list as well, right? So what I can do that, if you see on the router number one, let me create this bunch of route first of all. So I'll remove all this my loopback, no interface loopback number one. Okay, let me check whatever the interface loopback I have. So I'll better remove all this loopback, no interface range loopback 1 to loopback 7. Oh, 1 to 7. Right, man. The no from this one is invalid. Okay, we cannot remove it. Okay, no issue. I'll remove manually over there. No interface. Loopback 2, loopback 3, loopback 4, loopback 5, loopback 6, and loopback 7, and loopback 8 we have. I don't have. So let me get this loopbacks we have on the router one side, router 2 side. So on the router 2, I'll say the interface loopback number 1, IP address will be 101/24. Right? Interface loopback number 2, IP address will be 2.1/25. So it will go to 128. This should be go with the /26. So this guy go with the 192. 4. This guy go with the 224. This guy go with the 240. This guy go with the 248. Right? Interface loopback number 7. And this guy go with the 701, 242, 252. And then interface loopback number 8, I can also match the last one. 8.1. This guy will be the 254. Perfect, right? So I'm going to create this loopback and just go to the router 2 and put this command. Okay. So /31, it will not take on the loopback, but it will take on the physical interface. Not a big deal. So router EIGRP do show IP route. Okay, I think so. That was just a warning message. Yeah, this is just a warning message. It will take the 8. We have 8. Right. So now let me disable the auto summary behavior. Router EIGRP number 1, no auto summary. On router 1 as well. Router EIGRP 1, no auto summary. So now if you see, you will have a bunch of route on the router number 1. All these route. Do show IP route EIGRP. I have all this network now. We have 8.0, we have 4.0, 5.0/28, 6.0/29, 7.0/30, 1.0/24, and 2.0/25, and then we have 3.0/26. Now we are going to filter this route based on the prefix list. So the prefix list statement is very simple. So what you can do that, you just need to go on the router number 1 and say that IP, the IP means IPv4, you're going to do that. If you have a IPv6 prefix list, then you need to use the keyword IPv6 over there. So IP prefix list, and then you need to define the name of the prefix list. What name? Like a ACL, we have a number, and as I also told you that ACL also has a name-based ACL as well. I'll just put the name over there as the CCI, right? And now which action you're gonna allow it? Either you can say the deny or permit. So I say the permit, and now I can say the 191.1.0. I'm gonna permit this guy, and remaining automatically will be denied, right? So I'd say the router EIGRP 1 and distribute list prefix list and prefix list number CCI in mod. That's all. So by default, if I'm not going to put the sequence number over there, by default, the sequence number will start from the 5. In ACL, it start with the 10. In a prefix list, it start with the 5 over there. You can change this thing. Also, you don't worry about that. So the first thing, if you see right now over there, is what? Where's my main? I'm calling the /24, right? That's my subnet mask information or the wildcard mask information. So in an ACL, you're doing the wildcard mask. In the prefix list, you are doing the based on the subnet mask information. Okay, what happened to you, man? Okay, there's no list over there. All done. See, I have a 1.0 out. I just allow the 1.0. So remaining, what will happen? Remaining all will be denied. So by default, implicit deny is there like a ACL. We have same thing in the prefix list as well. Take example now, another one. What I can do that? Now I want to filter, take example. Now see the beauty of the prefix list. So this is just a one dot. If you not filter the one dot, you can just mention the one university 1.0/24. Just directly you can mention the submit mask information there, and that will filter the route. But take example, I want to filter the route that has a range will be start from the. I can see that okay, filter the route, whatever the route that has a submit mask information greater than or equal to the /29. So what I'm saying that whatever the subnet mask that has a greater than and equal to the 29, filter it. So all will be 29, 32, 30, and 31 will be filtered. So I'll just mention over there. Now I want to filter. I want to filter. I want to deny all the route. Those have submit mask equal to and greater than 29. So what will be the prefix list for this guy? Same simple one. I just saw the prefix list. See, same name. I'll see the word. I'm gonna deny it, right? So for the deny, what I can say that. So understand this concept. Match the common bit. Whatever the common bits we have. If you see, we have these are the common bits we have, right? These are the common bits we have. These are the common bits we have. So I'm gonna deny this particular route, right? So this in a third of it, we have a bits change over there 6, 7, 8. So I'm just gonna match the 16 bit. What I will say that 191.68 0 or 0. Match the 16 bit. Understand the command line. I'm saying that hey, match the 16 bit, but hold on. Look the submit mask. So till this point, what you have done, till this point, you just match the network portion. Till this point, you do what you have matched. You have matched the network portion. So basically, in the prefix list, what happened? We have two things. We have network portion and submit mask portion, right? So till this point, what you have matched, you have network portion, and then what I can say that over there, hey, greater than equal to the 29. So we have a very beautiful keywords over there, greater than equal to 29. It's gonna match the those has a submit mask 29, 30, 31, even the 32 as well. And what I can say that commit CCI allow everything. How are you gonna allow everything? You don't have any statement over there. Like ACL, we have any statement. We don't have any statement over there. So what you can say that over there, I'm just gonna call the 0 or 0 or 0 or 0. That's gonna match all the route. If I'm gonna put the 0 over there, what happened in that case? It's gonna match the default route. So you need to see this guy, hey, match the route who has a subnet mask less than or equal to the 32. Because IPv4 has a 32 bit, right? So I'm saying the less than 32 bit. And now I'm going to apply this guy. All good. Here we go. So I'll say I'll first remove the prefix list over there, CCI, and now wait for some time. So I must receive all the route. Great. And let's put this command. So already it is applied over there. I haven't removed the command if you see. So no need to apply re again, right? It's already applied over there. So I'll copy and paste it over there. Better too. we can see now, I don't have a 29, 30, and 31. We have a 27. We have a 28. We have a 24 as well. We have a 25 as well. We have a 26, but we don't have a 20, 28 also there, right? And we don't have a 29, 30, and 31. So this beauty that you have in the prefix list. Now, apart from the scalability perspective, it's amazing. Load perspective is just a minor load on the CPU side if you compare with the ACL. Another part is what? It's a very easy to configure, because in the ACL, what we are doing that we are doing the matching the bits based on the wildcard mask. Now we are matching the best bits on the submit mask information. So this is the task one. Let me write down over there. Prefix list. Right. Task one. Deny permit. Only allow. Right. Task two we have deny all the route that has submit mask greater than 29, greater than equal to 29. For this guy, the statement will be like this way, right? This is the task two we have. Same way, let's do the task three as well, right? In a task three, what I can do that? So let me put this guy over here a little bit. Yeah. So let me, if you see the prefix list right now, show IP prefix list, we can see the sequence number is by default 5, and let's go with the 10 over there, right? Take example. Always the increment of the sequence number will be 5. So if I'm default is 5, then it will go with the 5 plus 10. Then it will go with the 5 plus 10 plus 5, 15. Then it will go with the 15 plus 5 will be 20 over there. Take example, if your sequence number will start, if I'm going to manually configure the sequence number with the 2 over there, then the next sequence number will be plus 5. That will be 7. Next sequence number will be plus 5. That will be 12 over there. Next sequence number plus 5. So it's depend on the first sequence number. And in the first sequence number, they will keep adding the number 5 over there. So if you change this guy, let me show you this thing as well. Change the sequence number, right? So how you can do that? I'll same task I'm going to do that. I'll say that no IP prefix list CCIE, and I'm going to match this guy. I'll call the same person. And here we go. Instead of CCI, I'm going to put the sequence number there. Sequence number 2. And I'm not going to put the 5 or 7 over there. You will see that automatically it will go with the 7. 5. Okay. All done. And now you can see do show IP prefix list. You can see so 2 and now it's 7 over there. So it's totally depend on the first sequence number, right? Now let's do the task number 4. In a task 4, what I'm planning to do that now, I'm planning to filter the route, okay, that has a lesser than submit mask 28. So what I'm saying that, okay, below the 28, right, all will be filtered. So 28 will filter, 27 will filter, 26 will filter, 25 and 24 as well. Only allow the 29, 30 and 31. So same statement, you just need to change the greater than is the lesser than, and just need to put the 28 over there. So I'll just mention the task name, deny all the route that has submit mask equal to lower than 28. I'll call this guy, and here we go. Change this again, same bits, we need to match it. So if you see, we just match the 16 bit over there, right? And submit mask should be, sorry, match the 16 bit. And that's, I'm just gonna say that, hey, listen, lesser than 28. All that. So I say the no IP prefix list CCI, and here we go. All done. Wait for some time. And here you will see do show IP root EIGRP. All go. 29 is permit, 30 is permit, and 31 is permit. Now, so this is the greater than and less than, right? You can use the combination of this thing as well. Now, what I want to filter that out between to between. So I want to filter that out 26 to 29. I can do that. So then what you can do that? So task number 5, deny the route between /24 to not 20, 26 to 29. So same one, I'll just call this guy. Right? Sequence number doesn't matter anything. Just remove this guy, go with the 5 and 10. So now we have a 16, and now we have to call what? Greater than equal to 26, less than equal to 29. So I'm saying that, hey, match the submit mask that has a greater than 26, this one, and less than equal to the 29 over there. All and done. Wait. All done. Already applied is there, so no need to apply it. Meantime, I'll do one thing. I'll make a one default route. That's, I'm going to point to the 12 one. I'm going to redistribute this guy. Redistribute static. Okay, need to become the metric now. Static metric. Now let's go and check do show IP root. I can see that what we don't have. So the deny between 26 to 29. So we must not have 26 to 29. We have a 24. We have a 25. We have a 30 as well. And we have a 31 as well. And the default are, of course, right, that I just created, nothing else. Right? Same way, you can also do one thing. Task what? I'll say that 6. Deny everything. Everything. Allow default out. Allow only default out, I can say that. So I'm just showing you the try to the multiple combination, right? So so this is the basic command, right? You just need to apply in the route, this you can achieve it. I'm just trying to show you all the combinations so that you will not have any issues in the future as well, right? So now what you can do that, I'll just gonna allow everything. How are you gonna allow everything? Simple, right? Let me remove this guy first of all. So what I can say that I'm gonna allow everything. How I'm gonna allow everything? So the IP prefix list, right? Same name, CCI. And what I call this guy? Allow everything. Sorry, deny, I'm so sorry. Deny everything, allow default out, right? So simply I'm just gonna allow the default out, right? I said IP prefix CCI, permit what? I said 0 or 0 or 0 or 0. Perfect. And 1 minute. So I'm gonna allow the default out. So let's deny this guy. less than 32. And no less than, and I am going to allow this guy. No, this is gonna permit this person. Okay, that's all. No need to give the less than equal because this is gonna match the default, right? So you just need to call this guy on the router one. All gone, right? So I deny everything, allow the default only. So this is the way you can allow it. Same way, what you can do that. Task number 7. And if you want to block default route, how you can block it? So for example, let me remove this guy and say this block the default route. So answer the IP prefix list, format, CCI. I'm gonna allow block the default route. So I'm gonna allow the remaining one. So what I can say that deny, and that's my match the default route. And I'm gonna allow permit 0 less than 32. All we have. So this is all about the prefix list, guys. Very simple. So we have seen all the possible scenario, right? So this is the external route. If you see, this is redistributed. So we have filtered the external route, not the internal. So doesn't matter if you're doing the internal route filtering or external route filtering, both are same behavior. Anyone has a question, guys, in the prefix list? No? Okay, slow last but not
Not
least,
at the
I'm
moment.
just gonna show you the authentication now. So let me, that's fine. What I can do that, I'm just gonna apply the authentication. So the use of authentication is what? To just authorize the router. So take example. This is my service provider router, right? And so when router one is gonna form the neighborship with the service provider, then what happened? If the service provider has a 10K routes, 10,000 routes, so all this 10,000 routes will be received by the router one now because you just form the neighborship. So did you ask to the service provider, hey, please don't send this route? And maybe you just enable this interface into the EIGRP. And maybe what happened if this guy is attacker, right? Maybe this guy is attacker and they can send the dummy route. They can send the dummy route in your routing table, maybe the 20K routes, and your router is not able to handle this 20K routes. Then what happened? Maybe your router will crash, right? Because you haven't applied the authentication over there. So anyone can form the neighborship and they can send that out to you because it's all about what? It's a dynamic neighborship we have in this EIGRP, right? So we have a dynamic neighborship because if you're going to put the network statement, this interface will be enabled. And if this interface will be enabled, then what happened? Anyone can form the neighborship with you. And if anyone can form the neighborship with you, they can send the dummy route to your routing table as well. And if your router is not able to handle those amount of route, then what happened? Maybe your router will crash. So to avoid this problem, we can put the password over there, CCI, right? So whenever another hacker, right, if the attacker is trying to form the neighborship with you, he will prompt the password. Hey, could you please tell me the password? If the attacker doesn't have a password, he cannot form the neighborship with you. If attacker know the password, then they can form the neighborship with you. If they don't have a password, they cannot. So that's a very basic level of security that you need to do in the protection network. How you can do that? So right now you can see that I'll make a first, you need to make a keychain. It's like a first you need to get the lock, right? You need to create the lock, and for this lock we have a keys over there, right? So to kill the lock, we need to have a command for the keychain. That's gonna kill the lock. So I'll put the lock name is maybe ABC. Key ID, that's I'm gonna put the ID will be 1. And the key string, that will be your password, CCI123. So that's this part is my password. And now I'm gonna apply on the interface 0/0, because we are using the classic mode. We need to go on the interface mode, right? IP EIGRP keychain EIGRP protocol number 1 and EPC. That's a keychain IP authentication, and the mode will be EIGRP number 1 MD5. That's all. Now you can see that your neighborship gone. Enable authentication. As the keychain, CCI, sorry, ABC. Key ID will be 1 and key string will be CCI123, right? That's all. And then you need to go exit 2 times exit and interface 0/0 IP authentication, right? Then we need to define the keychain EIGRP1, and I say the keychain name is ABC IP authentication. Then you need to define the mode. What mode you're going to use it? I'll say the MD5 over there. Same command you need to do on the router number 2. Make sure that this key string must be matched, right? If you're gonna use the keychain over there, XYZ doesn't matter. Keychain doesn't matter. This name is a locally significant, it doesn't matter. But this should be matter always. So if you see right now, router 1 has dropped the neighborship with the router number 2, and I don't have any doubt over there. Because I put the password over there. Now the password is what? CCI123. So when he's trying to send the hello packet, in this hello packet, they don't have a password. So when he's trying to form the neighborship, he's asking, hey, do you know the password? He said, no, I don't have a password. So you cannot form the neighborship with me. So if you see right now, from the hello packet from the router number 1, I'll show you in the capture. Let's have a look from the 2LR2 right now. So if you see the 2LR2, you don't have any authentication field. Can you see that? Because I haven't applied any authentication on the R2 side, right? But if you check on the router number 1, now you have authentication field. That's a password that I have applied over the digest value. So router 1 is setting the password, but router 2 doesn't have a password. See the router 2 hello packet. It's empty. There is no authentication field even over there. Right? So we need to put the same password on the router number 2, otherwise they will not form the neighborship. If you see, my neighborship is not there. EIGRP neighbor, I don't have a neighborship. So copy and paste it. Oh, what happened? There's no icons over there. All done. So now authentication has applied, they will form the neighborship. So now both the hello packet has the authentication data. So this is the router number 1. So same authentication we also did in the name mode. If you guys remember that, we have seen the HMAX. Classic mode has an issue. Classic mode doesn't support it. So if you want to go with the advanced level of authentication, then you need to go with the name mode. Anyone has a question, guys, in the complete EIGRP, I'm done. I've also shown you how to change the hello timer and hello time and hold on time. If you remember that command, right? Don't change it. Never ever recommendation to change the hello timer in the protection. You will never ever do that. IP hello interval. Yeah, you can put the command for the EIGRP number 1. What hello, change it. So right by default is a 5 second. You can make it 20 second right now. And okay, auto so 20 second, and that's fine. and IP hold on time, EIGRP number 1, I can make this guy the success again. So this is the how we can change the hello time and hold on time, but never ever changing the product set, never. Because if you're changing the hello interval and hold interval, it creates the issues. It impacts the convergence time over there.
Oh, okay.
And IP hold on time, EIGRP number 1, and it go with the 60 seconds. That's a hold on time. I'm done, guys. Anyone have the questions? Hello.
One question, sir.
Yes.
Sir, if router one in router one authentication is applied, how can we know?
Based on the command.
Sorry, sir.
Based on the command.
Yes, sir.
So keychain.
So keychain.
Okay.
Okay. If not configure, then sir blank.
Yeah, it's a blank. Nothing will be there. So if you remove the keychain, you will not have anything over there.
Keychain is apply or not? The command is show keychain.
So keychain, yeah.
Okay, okay. Thank you,
Even
sir.
if you see that, I might show you in the hello debug EIGRP packets. Debug EIGRP packets. Hello. I might see in the hello over there. So normally, anyways, you need to when you do the configuration of the EIGRP and when the other person is trying to form the neighborship and he could not able to form the neighborship, then he will ask the password. So anyways, you will get to know that there is a password applied, because when you're going to form the neighborship with another router and you're not able to form the neighborship, it is still you have a disability. Then what happened? Maybe the password will be there, right? So even you can check with the debug command as well.
Okay.
Anyone else? Any question, guys, in the EIGRP?
Okay. So, sir,
Sir.
please. Okay. So, sir, please. Okay. So, in case you have about 20 routers, that
Okay.
means you have to set the password on each of them.
Yes, you need to manually go and box by box configuration. You need to do that.
But then, apart from going box by box, is there any automation that you can use?
Yeah, automation is there. Automation, you can do that. You with the help of automation, you can do that, this thing.
Okay, that's fine.
But for that thing, you need to must have a knowledge of the Python and the scripting language, right?
Okay.
Yeah.
Okay, thank you very much.